Let's continue recursion. I take the factorial 5 for the example, right? Normally we represent a factorial like this, right? Right? Normally how can we represent factorial 4? Right? Factorial 4 equals to 4, 3, 2 and 1, right? Like this. We can represent factorial 4 like this, right? Instead of this part, we can use factorial 4, right? Like this. Factorial 5 equals to 5 4's factorial, right? We can represent the this like this, right? Now we can represent factorial 4 like this, right? Factorial 4 equals to 4 multiplied by factorial 3, like this, right? And again we can represent factorial 3 like this, right? Again, you can represent factorial 2 like this. Right. Now you can represent factorial 1 like this. Factorial 1 equal to 1, right? This is the base case for factorial, right? Now, according to our equation, n equals to 5, right? N equals to 5, right? N mean 5, right? Factorial n minus 1. 5 minus 1 is equals to 4, right? I think you can understand these things, right? N minus 1 equals to factorial 4, right? Now you can understand the equation and process, right? At the base case, we should stop this process, right? Okay, the Fibonacci. The Fibonacci sequence is a set of integers, right? That start with 0, right? Start with 0. Right. According to that rule, our first number is 0, right? Fibonacci has two base cases. Those are 0 and 1, right? This case has two base cases, right? Right. I write this line. I want to find fifth value of Fibonacci, right? The first two numbers should be 0 and 1. According to that rule, second number is 1, right? Now, we have a rule. Rule is each number is equal to the sum of the presenting two numbers, right? Presenting two number means third value should be equal to sum of these value, right? 1. Therefore, third value is 1, right? What is the fourth value? Fourth value should be sum of these two numbers, right? 1, 1, 2, right? What about 5? You should get the sum of 1 and 2, 3, right? If you need to find fifth Fibonacci, you should use this and find it. Fifth Fibonacci value is 3, right? The answer should be 3, right? According to this, you can understand this presentation, right? Fibonacci 5. We can get Fibonacci 4 and 3. We can get Fibonacci 5, sum of Fibonacci 3 and Fibonacci 4, right? Fibonacci 4, we can get it sum of Fibonacci 2 and sum of Fibonacci 2 and 3, right? Then 3, we can get it through sum of 1 and 2, Fibonacci 1 and 2, right? I think you can understand this series, right? If n is equal to 0, what about Fibonacci value? Fib value should be fib n, right? Equal to 0, right? If it is equal 1, n is equal to 1. What can be if it is n equals to 1, Fibonacci value should be equal to 1, right? And if n is greater than or equal to 2, what about Fibonacci? Then it should be fib n minus 1 plus fib n minus 2, right? You should remember these things, right? We already explained about infinity recursion, right? Think we have two numbers like 6 and 12, right? We have to find the greatest common factor between them, right? Before finding the GCT, we should find the factors of those numbers, right? We can divide it from 1, 2, 3 and 6, right? We can divide 12 from 1, 2, 3, 4, 6 and 12, right? Yeah. Then what are the common factors? 1, 2, 3 common. 6 is another common factor of 6 and 12, right? What is the greatest factor? Greatest factor is 6, right? Therefore, GCD equals to 6, right? Right. Let's talk about recursive definition to get the sum of the first n positive integers, right? Think I need first 5's sum, right? We can write it as 1 plus 2 plus 3 plus 4 plus 5, right? But in the recursive way, we can write it like this, equal to n plus like this, right? N means 5. 5 minus 1 means 4. Likewise, we can continue like this, right? N minus n plus sum of n minus 1, sum of n minus 2, likewise, right? You can continue. Also, we have a base case, right? Base case is n equals 1, right? If n equals 1, what the value of sum? 1 equals 0 mean 1, right? This is the base case, right? And this is the recursive way. In the recursive way, n should be greater than or equal to 2 or something, right? N should be greater than 1, right? Not equal, right? Topic is recursive definition for multiples of 3, right? In this case, what is the recursion function of this? F function equals to 3 multiplied by 8, right? This is the equation. 3 is the consonant value, right? And n can be changed. N can be changed. Hurry. And we can write like this. Wait. Write it this. Right? F1 mean n is equal to 1, right? 3. F2 mean n equal to 2, therefore 3 to 6. You can continue these steps, right? And we can represent this in mathematical versions like this. Fm equal plus 3, right? If n minus 1 mean previous system, right? Like this. F1 is equal to 3, right? Now F2 mean F1 value plus 3, right? And F1 value is 3 and 3, 6, right? What is F3? What about F3? Previous value is 6, right? 6 plus 3. Fn minus 1 is previous value, right? It means if it is F3, you should get F2's value plus 3, right? Then you can get F3's value. If you get something from this video, don't forget to subscribe us, like, comment and share. Bye bye.